In this lesson, we are going to find the time period of a simple pendulum by the energy method. This is again very simple. This is a simple pendulum. When the pendulum is in this position, the torque is 0, potential energy is minimum, and this position is called mean position. If you don't know the spelling of mean, you can call it stable equilibrium position. Now, since the potential energy is minimum, we can call it 0. We can take the reference line for potential energy anywhere. So this position we can take as the reference line, and we can say the potential energy is 0. Now, when this pendulum is at a displaced position, it would have gained some height, so it will now have some potential energy. Also, it will have an angular velocity, unless that is the extreme position. So let us consider an in-between position. So the angular velocity can be in either direction. Let's say the angular velocity is in this direction, and this angle is theta. So now the pendulum has moved up by some height. So we want to find its potential energy with respect to this reference line. So we need this height. The length of the string is L. This length remains constant because the string remains tight. So now we have to find this distance y. And once we know y, we know h, because h will be L minus y. Here we have a right angle triangle whose hypotenuse is L. This angle is theta. If in a right angle triangle we know the hypotenuse and we know one of the angles here, okay, 90 degrees anyway we know. So then the adjacent side is L cos theta and the opposite side is L sin theta. That is very simple. It comes from the definition of sin and cos. So if this is L, this will be L cos theta. So therefore, in this situation, y is L cos theta. If y is L cos theta, h, this one, this height h, will be this L minus this y. So therefore it will be equal to L minus y, but y is L cos theta, so h becomes L into 1 minus cos theta. Now the potential energy at this position is simple formula mgh. So potential energy will be mgh, and h is L into 1 minus cos theta. This bob is in pure rotation about this axis. So therefore its rotational kinetic energy will be half I omega square. So the kinetic energy in this position is half I omega square. In SHM, total mechanical energy is constant. So therefore kinetic energy plus potential energy will be constant. Kinetic energy is half I omega square. Potential energy is mgl 1 minus cos theta, and this will be constant. And if we differentiate a constant with respect to anything, we get 0. So we can differentiate this equation with respect to time, and that will be equal to 0. Half and I are constants. If we differentiate omega square we get 2 omega. We are differentiating with respect to time, so differentiate again omega with respect to time. We'll get d omega by dt. So now, what we have done? We have differentiated omega square with respect to time. So first we differentiated omega square with respect to omega. We got 2 omega. Then we differentiated omega with respect to time. Then we have got mgl. If we differentiate 1, we get 0. If we differentiate cos theta, we get minus sin theta. There is a minus sign here. So this will become plus sin theta. And we have to differentiate theta again with respect to time, because we are differentiating this whole thing with respect to time. So we'll get 1 d theta by dt. And this will be equal to 0 because total energy is constant. This 2 gets killed and we get I omega d omega by dt is alpha, mgl d theta by dt is omega, and sin theta is approximately equal to theta in radians when theta is small, that is less than 6 degrees. So we can write this as theta equal to 0. Okay, theta is small. And once we have done that, we can get the equation for alpha. So basically, I omega alpha is equal to minus mgl omega theta. Omega cancels out. Alpha becomes minus mgl by I into theta. I is mass into distance square. This bob is almost like a point mass, and the distance is L from the axis of rotation. So its moment of inertia about this axis is ml square. So this becomes minus mgl by ml square into theta. M cancels out, 1L cancels out. So we get alpha equal to minus g by L theta. In SHM, alpha is minus omega square theta. Therefore, omega is root over g by L. And if omega is root over g by L, then time period will be 2 pi by omega, and that gives us 2 pi root over L by g. So this is how we derive the formula for time period of a simple pendulum by energy method.